everybody. Excuse me. Welcome to part 2 of week 4 webinar, where we're going to look at one of our checks of data integrity, the power analysis. This is much easier to learn once you've gone through a few statistical tests like we've already done in this week. So step 2, check of data integrity, power analysis, brought to you by William O'Bannon of Stats Whisperer. So again, we always want to keep in mind where we are in the 6-step process of data analysis. And so we're right here in step 2, right? We're making one of the checks of data integrity, the power analysis that will tell us if we have enough people in our sample to answer our research question or hypothesis. So in this presentation, we will not only define power analysis, but we will also apply power analysis to some of the bivariate tests we've gone over and the multivariate tests we'll learn next week. Now, what exactly is power analysis? Put briefly, power analysis is what's used to calculate the sample size or number of study participants needed to detect a relationship between variables, such as the independent variable and the dependent variable. Now, if I were going to do a study, pardon me, and the study was about eating fruit and being happy, where happy was happy, yes, no, right? And then I had 4 people in my sample. 2 of them were unhappy on the right, and 2 of them were happy on the left. And then I looked at the rate of eating fruit, and I said, the 2 happy people both eat fruit. That's 100% happiness. But the 2 people on the right who are unhappy, only one of them eats fruit. So that's 50% happiness. So I deduce eating fruit is related to being happy. And somebody might come along and say, wait a minute, that's only 4 people. You can't conclude, you can't conclude that relationship based on 4 people. So the question becomes, how many people do I need? So suppose instead of 4, I have 4,000. On the left, I have 2,000 people who are happy, and they all eat fruit. On the right, I have 2,000 unhappy people, and 50% eat fruit, and 50% don't. Well, then it's a little more credible, right? Because I have 100% of 2,000 people happy, but only half of 2,000 people happy, depending on eating that fruit. So I might say that where 4 is too little, 4,000 is probably too large. You probably don't need 4,000 people. So just how many people do you need? So that's what the power analysis will tell you. So power analysis has 4 dimensions, right? You could call it a dish of 4 ingredients. There's statistical power, number 1. Number 2 is the level of probability, or alpha. Sometimes they call it alpha. Number 3 is the effect size, and number 4 is the sample size. Now the trick is if you can set ingredients 1 through 3, the 4th ingredient will be revealed. Now, 1 is relatively simple. Power must be set at least 0.8, right, or 80%. So sometimes they set it above 80%, but really it must be at 0.8 or above to detect a relationship between variables. Probability, or alpha, as it's called, is set at least 0.05 usually, right? So that's standard. So we have 2 standard settings. So Linda Richmond from Coffee Talk would tell you, at Coffee Talk, we can tell you ingredients 1 and 2 are no big whoop. Power set at 0.80 and probability at 0.05, right? Because that's rather standard, it's rather evident, unless there's special circumstances to manipulate them. Now the next one is effect size. And the big question here, as Linda Richmond says, is do you want a small, medium, or large? But it's a small, medium, and large effect size, not coffee. Right? So the effect size setting, right? So we're looking at what magnitude between the relationships, between the variables that we're looking for. So if we have a treatment, right, and that's our independent variable, such as, treatment to reduce smoking, and the outcome is number of cigarettes smoked, we want to say just what size effect does the treatment have on the number of cigarettes smoked, right? And do we want to look at a small, medium, or large effect? Now, a lot of people might say, why not always just look at a small effect, right? That way, all your bases are covered. If you find a small effect, you know that the medium and large, you know what I mean? The distance before the medium and large. Well, the trouble with that is it could be so small that the effect does not matter, such as if the treatment had a small effect to stop smoking, right? But it cost a lot of money, tens of thousands of dollars, and had a lot of side effects, you wouldn't care if it had such a small effect, right? Because a small effect, you wouldn't pick up the program, right? You would only care, say, if it had a medium or large effect in viewing how much money it costs and all the side effects, right? So the key is to look at the smallest effect that's still substantive. Also, and this is probably a more common reason for looking at a medium or large effect, you need a bigger sample to detect a smaller effect. You need more people in your sample to detect these smaller effects. So if you have a limited sample size, you may only be able to detect a medium or large effect. So let's say you're doing a study, right? And you have to collect your own data, and you have limited time, money, and resources. Well, you find out to detect a medium effect, you need 100 people. To detect a small effect, you need 150. So based on your resources, you can only collect 100, right, data on 100 people, and then you can only detect a medium-sized effect, right? Now, this is important. The effect size, raw number, conceptually it's the same. It's small, medium, and large, but the raw number varies from test to test many times. For example, in a t-test, a small effect is 0.2, a medium is 0.5, and a large is 0.8. And in multiple regression, a small is 0.02, a medium is 0.15, and a large is 0.35. So there you have it, right? We have our settings. So we have our statistical power set at 80%, probability or alpha at 0.05, and the effect size set at medium, for example. And once you plug those in to a software doing power analysis, it'll tell you the sample size you need. The last detail is that sometimes a power analysis will ask you if you want a one-tail or a two-tail test. Now, a one-tail test is if you only want to examine the relationship if it goes in one direction, right? Like we're looking at happiness and aloofness. If you only care if aloofness goes down as happiness goes up, and you don't care if it goes up when happiness goes up. That's one tail. But most studies are set at two tails, right? And that's what I would do, because you really have to justify one tail. So most studies are set at two tails. If you ever get the option, you might want to think about two-tailed. Now, there are many software programs that are available for free to do your power analysis. Power and Precision is a very very common and widely used software program for power analysis. They have a free 30-day trial. But G-Power, and you see the addresses for both are here, G-Power is free, right? And that's what I use to base the computations in this this webinar, right? So you can go to that, and that's free. And that'll ask you just to specify the test. You put t-test, and you'll say statistical power is 0.80. Probability or alpha, that's one of the programs where it says alpha, right? It's right underneath it. It's 0.05. And then it even lists the effect sizes for the test. And so you'll say the effect size. So in the three boxes, one on top of the other, you put the power 0.8, the probability 0.05, and the effect size 0.5. And then you click calculate, and it'll give you number 4, the sample size needed. Right? So it'll say, based on those settings, you'll need 122 people to look at a t-test. You know, that looks at, you know, the two category variable and a continuous outcome. Now, one good question you might ask is, if you're doing a study, when the study ends with multiple regression, but before that you use a t-test and a chi-square and then an over, do you need a power analysis for each statistical test? And the answer is no, not usually. Usually, in the proposal or the paper, there'll be one power analysis, and it will be used for the final multivariate procedure. So you'll just in that case, even if you did t-tests, chi-squares, you end up with multiple regression, you would do a power analysis on multiple regression. So here we go. Multiple regression, this again is in G-Power. We have statistical power set 0.8, level of probability at 0.05, and the effect size at 0.15, right? That's the medium size effect for multiple regression. Right? So then what's the sample size needed? And G-Power would tell us, also we have to specify the number of predictors. So multiple regression, the number of predictors affects the statistical power. So we have to specify it. So if one independent variable is treatment, right, that's one predictor, and then say we think treatment will vary by age and gender, so those are two control variables, that would be 3 predictors in our multivariate regression. So we have our settings. The power is at 80%. Probability alpha is at 0.05. The effect size is 0.15. And G-Power says you need 77 people to detect a medium-size effect between the independent variable and dependent variable in that model. Right? So the point of it all, oh, and also don't forget, if you want to go for that small effect, it increases the sample size dramatically. So that same model, if we change the sample size from 0.15 to 0.02, right, our sample size needed goes from 77 to 550. So if you're collecting the data, the difference between collecting data for 77 people and 550, you know, could be substantial. So that's also a consideration in picking your effect size. It's called practicality, right? So in the proposal, after doing your, or the paper, after doing your power analysis, you might write something like this. Based on G-Power estimates of multiple regression with power set at 0.80 and probability set at 0.05 using 3 predictors, a medium-size effect, 0.15, would be detectable using a sample of 77 study participants. Now that's very good to know, right? Because it's better than just wondering if you have enough people in your sample, right? You could specify how many people you need, and what size relationship it will indicate. It looks very professional. Okay, I'll talk to you at the next webinar. Okay, bye-bye.